pressure. In other words, the higher you're calling the water, the more pressure on that jet at the bottom. And then there's back pressure, because if you just have a hole in the side of the tank, there's nothing really restricting that upward flow. There's no resistance and no back pressure. But apparently this was leaking to the bottom of the tank, so you did have back pressure coming up from the ground to some extent. And we don't know what that back pressure was. So in order to do even a rough calculation, I had to ignore both head pressure and back pressure. I just assumed both were zero. And in a low head environment, saying they cancel each other out, how long would it take 7,500 gallons to drain through a 1-inch hole? And I come up with about 912 minutes or something slightly over 15 hours. That's assuming you had a 1-inch hole the whole time. You may have had a 1 millimeter hole 3 months ago. We don't know. With corrosion, and it's likely is a corrosion-generated hole, and that's normally what causes tanks to fail. They generally grow. So you have a corrosion point, it starts growing, and it gets to the point where something very significant happens. So I'm not saying that all of a sudden one day we woke up and had a hole in the bottom of the tank where there was no hole before. So again, bear in mind all these qualifications. But you could, what I'm getting at is you could presumably drain that amount of material out of the tank like that over a period of 15 hours. Using those numbers then, is that 15-hour value, like this on this tank. If you took that massive material and put it in the flow that day of the Elk River, you would get a concentration of NCHM of about 7 milligrams per liter, if it was perfectly mixed. Another bit. Now, in reality, both Freedom Industries and the water intake are on both sides of the river, on the same side of the river. So you're going to have a tendency for that water to follow the bank for some distance until it disperses. There's a significant flow in the river, so there's some current. But my guess is that actual number that arrived at the intake would be higher than that. It couldn't be any lower than that. I thought it would be any lower than that. So you could be up 2 or 3 times that number. And by the time you get out onto the canal, assuming making all the same assumptions, with its flow, which was maybe 7 times higher than the Elk's flow, you're down around 1 milligram. Okay. On the subject of requirements for containment structures, there is EPA legislation, 40 CFR, the Federal Regulations 112, which is oil pollution and prevention. That's the act. And it has all manner of conditions, but it applies to petroleum oils and non-petroleum oils. So it applies to peanut oil, for example. If it's an oil, it's an oil. It doesn't really care what kind of oil it is. Now, you'll notice that, remember, the structure of this thing is basically a hexane molecule with an methyl and an alcohol stuff to it. So you're starting out with hexane, which is a major ingredient in gasoline. Also applies to any above-ground tank that's larger than 1,320 gallons. Remember, this tank was 48,000 gallons, so it certainly qualifies as a significant-sized tank. It includes production as well as storage and distribution tanks. Not just production tanks, not just production facilities for oil and gas operations, but distribution, storage. And the point of this whole act is to prevent discharge of oil from non-transportation related facilities to the navigable waters of the United States. And you'll notice that there is a barge terminal right at the site, so it is certainly a navigable water under the containment's definition. All right, I repeat this again because, again, the definition of this stuff is it is an oil. So, under CFR, 40 CFR 112, you have something, you have a requirement for an SPCC, which is a spill prevention, control, and countermeasures plan for any of the tanks that qualify. And this could be below ground tanks, partially buried tanks, or above ground tanks. And again, I'm not an attorney, so bear with me if I'm completely misunderstood the reading of this thing. But the way I understand it, all big tanks, they have oil in them, not to have an SPCC plan. And this is some of the language from the act that I copied here. These are some of the key elements of what an SPCC ought to involve. And this is the big one, a secondary containment structure that can contain the expected discharge from a tank on that site. means it has to have a bottom seal, it has to have berms, it has to have the right size, it has to be leak-proof. That's the plain language out of the act. You have to file a description of the material in each tank with the appropriate authorities. You have to have an emergency response and notification plan as part of this. And you have to have regular inspections and reports filed on inspections. And in this case, this is right out of the act. The inspections involve tests and records. So you have to conduct these inspections and tests in accordance with a written plan that you got on file with your regulatory agency. And you have to have it certified by a professional engineer. You have to keep these written records and procedures and a record of the inspections and tests signed by the appropriate supervisor or inspector on record for 3 years. That's the process. So, it's the long and short of it. The long and short of it is that this wouldn't have been a problem if appropriate secondary containment was installed on the site.
Okay. Questions? Members, questions? Delegate Purdue.
Thank you, Mr. Chairman. Doctor, can you tell me, as you research, have you been able to indicate what other substances have the LD50 similar to the LD50 for this substance?
Lots of things. It's not the highest LD50 you're going to find, so it's sure it would not qualify as a particularly toxic material.
That's what I'm saying. The other thing I wondered about, this is a methanol type compound.
It has the methanol group.
Right. Right. It is not a, is it flammable?
Yes.
Okay. Is this particular methanol in and of itself to be somewhat corrosive? Is this known to be any more corrosive than any other?
To the extent that it is slightly water soluble and it is a surfactant, you would expect it to pick up some water molecules and hold them in solution. How much of that actually happens? Even auto tanks are done different roads, so I'm sure wood or
Does methanol itself have the same LD or a higher LD50 than this compound?
it actually has a higher, I think I looked it up last night, I think it's higher. Yeah, methanol is not very good.
Well, no, but wood alcohol with its history and some of the things that's happened with it over the last century, I just was interested to know whether it had a higher or lower LD50.
My recollection is it's higher, it's something like, I think it's 4,000 milligrams per kilogram. So it's a higher level, so it's less toxic than
If this tank were filled with nothing but methyl alcohol, it would not be an oil. Is that right?
it would not be oil, correct? There's pure methyl alcohol.
Sure. Thank you.
Further questions? Senator Miller.
The SPCC regs, that means we know where every tank is that contains this.
Every tank that's over with oil, it's permanent or even mobile storage units within a facility with an aggregate total over 1,329 gallons should have an SPCC.
And that's filed where?
Where should it be filed?
Yes.
The cognizant authority, I don't know which agency is responsible for that. Yes,
So we have a list that all those are probably know is filed. Thank you.
Jay, did you want to help answer that question? Or?
Well, federal, I'm not really sure which federal agency has oversight, but it might be OSHA. Oversight of that program.
They would have.
Right.
We need to find out.
Right.
Further questions? Delegate Purdue.
I'm sorry, I had to follow up. Does the compound silt out appreciably in a riverbed, for instance?
I wouldn't expect it to.
It's probably, yeah, its quality seems to indicate it would.
Yeah, it's because it's lighter than water, so
Right.
it'll tend not to lay on the bottom like heavy oil would.
Does it convert to a lot of things easily?
That's not known. That's a good question because I did look for that to see what kind of secondary compounds would be developed, and I haven't find any information on that.
Thank you. Mr. Chairman. I talked briefly with some other people with chemistry backgrounds, toxicology backgrounds, and they indicate that there's potential, and I just would like to, get this clarified from you, that this chemical has the potential to break down into other chemicals through the chemical reaction or breakdown through microbes or other processes. And I wanted some input as to what these chemicals could be, the toxicity of them, the carcinogens.
I don't have time to answer for that. Just, my knowledge has not been well characterized. The compound itself, and as part of the SDS sheet, requires an indication of carcinogenicity, teratogenicity, which is birth defects. There are no indications found in any of the MSDS sheets that I found that it was ever determined that it was either carcinogen in itself.
But if this chemical were to react with chlorine that's in the water, or ammonia that they may use to extend the life of the chlorine, or fluoride that may be in the water, this chemical reactions, what is the potential for creating a more dangerous chemical than the chemical that we have?
That really is a good question, because when water passes through a water treatment plant and it's chlorinated, and it's oftentimes chlorinated with chlorine gas, that starts to add chlorine to some of the organic compounds, So things like trihalomethanes, where you start getting chlorines around the methane ion, those are regulated by the federal Drinking Water Act at 80 micrograms per liter. So total trihalomethanes is one component that generates a great deal of toxicity, and it's because it is carcinogenic. Now, this is a much bigger molecule than just the methane, but as it breaks down, whether that methyl starts to break off, the methyl group, which is basically methane stuff inside the hexane. So whether you start getting release of methane itself, I don't know.
Do you think there's any potential for affecting the aquatic life in the river or the ecosystem within there?
We did find some information on concentrations that were known to be damaging, that would generate an LD50 for minnows and daphnes, which is basically a small population which uses it as a test for toxicity. And those numbers were up in the multiple milligrams per liter, like 10, 20.
But if this isn't bioaccumulative, it's not really going to hurt the ecosystem of the river or anything in the long term.
I would expect it to move through fairly quickly. That's based on not much information, but I would expect it to move through fairly quickly and not just stick to a lot of things. And I would expect if it had been really harmful to fish, I would expect it a fish kill. You're not going to get a fish kill now because the concentrations will be dropping from the release date forward. So I haven't heard any information or any indication that there was a fish kill or health.
Thank you very much. Thank you.
Further questions, members? Questions? Paul, in regards to the institute itself with the research, what, maybe it's too soon to ask you this, what recommendations do you have in the sense of looking at the situation? I know you identified that the SPCC regulation, you're not sure who's supposed to inspect or where that's filed, but there's something on the books, and evidently there's a deficiency within that area. And also with the intake, just 1.6 miles down from such a facility, and the intake only be one intake, serving 300,000 people. Other waterways, I think up in Morgantown, they have actually two intakes, don't they? They serve what, 40,000 people or something?
At least maybe 120.
Maybe 120,000, they have two intakes.
Yes.
That's the American Water Company that serves 300,000 people, only has one intake.
Yeah, Morgantown has, if we rely on Chokin Creek at the Monongahela River itself, becomes unsuitable.
And I heard that as this chemical was going down the river, there's going to be believe in Cincinnati that they actually shut down one of their intakes and started withdrawing water from another intake and letting this chemical just float on by. Do you have recommendations, or would your institute help board help us with drafting recommendations and where we need to go in order to protect our water resource?
Yes, absolutely, that's part of our responsibility. In that sense, I would say that there are a couple things that need to be addressed, and we already talked about the SPCCs. The other thing is, once this compound like this, it could be any compound, things that are much worse than There are two exposure elements, or almost two phases to the distribution of this material through the environment. One is down the rivers themselves. And then the other thing is, and this is proving to be much more problematic, which we predicted, and that's the residence time in the distribution system itself, once it gets into the pipes. Because once it leaves West Virginia American Water, normally what happens is that water is pumped up to storage tanks for local communities and then distributed out from those big storage tanks. And these are big storage tanks. So that's a significant residence time. So you don't have necessarily straight pipe going out for the water treatment company itself out to someone's faucet. So you have these intermediate stages of water tanks. You also have temporary storage in schools. They can have a cistern, or an institution. They have a cistern, water handling systems. So you have these storage components within those systems. And those can be modeled to try to get an idea of how long it would take to, and what's the most efficient way to flush something through a system once it gets in. The other thing is how long it takes for a contaminant to start moving into a system, and at what points you need to start shutting down parts of your system if you get something past your initial intake. So that's a modeling problem that we're trying to find a way to address right now. So and that would be very, very important for the water companies to determine whether or not 300,000 people have to turn off their water, or 30,000 people have to turn off their water. So just trying to figure out what the rate of distribution of contaminant through a system is